In today's video, we are going to be studying chemistry, and this topic we are looking at has to do with concentration of substance in solution. When you're dealing with concentration of substance in solution, or any compound in a solution, or a salt or acid base, as the case may be, there's basic thing you need to understand whenever you want to solve a calculation that has to do with this. For example, what we have here, the question said calculate the mass of normal salt formed when 500 cm cube of 0.5 moles per dm cube of sodium hydroxide were completely neutralized by a solution of tetraoxosulfuric acid. Now we are given the relative molecular mass of sodium hydroxide, which is 40. Now when you look at this question, the first thing where you will pay attention mostly is here and there. 500 cm cube and 0.5 mole per dm cube. What does that mean? Because this is the beginning of the solution. The beginning of the solution. If you are to solve this problem, you need to understand how to handle this situation. Now I said we pay attention to these two. If you look at this what we have here is in 500 cm cube, and here what this information, the information we have here is that 0.5 mole per dm cube. That means in 1 dm cube we have what? 0.5 moles. That is what we have in 1 dm cube. We have 0.5 moles in 1 dm cube. So if it's so, it means we know that 1 dm cube or 1 liter is equal to what? 1000 cm cube. And we're looking at this one in unit of what? Cm cube. So we'll consider that based on what? Cm cube. Here we have, it means that in every 1000 cm cube, we have 0.5 moles. So the first step to solving this problem is to understand the relationship, this relationship that exists here. Now, the next one, since every 1000 cm cube contains 0.5 mole, what will 500 cm cube contain? Because if you're able to get the number of moles we have in 500 cm cube, that means you are already halfway to the solution of the problem. Now, what does it mean? Now, how do we get that? Let's look at that. It means that 500 cm cube will then be equal to 0.5 over 1000 times 500 over 1. If we cancel out, then this will go, we have 0.05 mole. That 0.05 mole is what we have in what? 500 cm cube. But that is not the end of it. Now note, they say that we should calculate the mass. To get this mass means we need to know also the mass of sodium hydroxide that is inside this 0.05 moles. So how do we do this? Now we know that mass and mole is equal to mass over what? Molar mass. Molar mass. So since it's this, what we do here is that we know that this relative molecular mass is equivalent to the molar mass when expressed in grams, because we know that molar mass is always expressed in what? Grams or per mole. Grams per mole. So now we can use it in place of this what? Molar mass. Now we don't have the moles. The mole we have in 500 cm cube is what? 0.05 mole, which is equal to mass. The mass we are looking for is what we don't have here. The mass is what we are looking for. We don't have the mass, but now this will serve as our molar mass, which is 40. So if you cross multiply this, when you cross multiply it, we have that mass will then be 0.05 times 40. So when we do this, what we will get will be 0.05 times 40. That is, it will give us 2 grams. 2 grams is what we have in what? 500 cm cube. Now we are halfway to the solution. Like I said earlier on, this is now we are halfway. Now what else are we going to do? How are we going to get this thing done? One may ask, how are we going to do? Is that all? What next are we going to do? Now we're going to be looking at we're going to compare the what stoichiometric relationship that exists here. Now in every balanced chemical equation, that is basic thing we can find there. Now let's look at the balanced chemical equation in order to know exactly what happened. Now in a balanced chemical equation of a reaction between sodium hydroxide and what? And tetrasulfur 6 acid or sulfuric acid, what we have there will be sodium hydroxide reacting with sulfuric acid or tetrasulfur 6 acid to give us sodium sulfite or sodium tetrasulfur 6 plus water. Now I think the equation is now balanced. So this is what we have. So based on this, remember in a balanced chemical equation there are some basic information we can get there. Number one, mass, the reacting mass, the mole ratio or the number of moles that is reacting. We can also get it from what? A balanced chemical equation. So from here, because we are talking about mass, we can limit whatever we are doing now to mass. Although, perhaps if we are looking at the moles, we can say that this coefficient we have here is equivalent to the number of moles that is reacting of sodium hydroxide. Why this one is what? 1, because it does not have any number here, any coefficient there. And this other one is giving us what? 1. And this other will give us 2. Which means 2 moles of sodium hydroxide react with 1 mole of sulfuric acid or tetrasulfur 6 acid will give us 1 mole of what? Sodium tetrasulfur 6 salt, which is a normal salt, the one we are looking at here now, which is a normal salt. Now, and what? 2 moles of what? Water. This is what we have. Now, if we're looking at the mass, now, what it means is that 2 moles, the number of moles times what? Molar mass, because molar mass of sodium hydroxide is what? 40. That will be equal to what? 80. Now, because that's what we are looking at now. And then, from there, we will get the molar mass of these two. The molar mass of this, or number of the mass that is reacting. The mass that is reacting now, since we don't have any, this is just 1 mole, we know that sodium is 23, and we have number of sodium we have here is what? 2. Number of sodium we have here is 2, plus sulfur, which is 32, but then hydrogen, which is 16, and we have 4 hydrogen there. That will be 16 times 4. That will give us 64, to give us 64. So, sorry. We have 64. So now we have 64 here. Then we add it up. If we add up whatever we have here, if we add up everything, what we have 20 times plus 32 plus 64, what we get is what? 142 grams. So here we have 80 grams will give us what? 142 grams of sodium tetrasulfur 6. That is what we have. This is what we are looking at, because these are the two things we are comparing. We are comparing these two. Now, based on what we have so far, we say that it's 2 grams. Now, since 80 grams will give us 142 grams of sodium tetrasulfur 6. Now, what will this 2 grams give us? What we have here will then be, we say that 80 grams is equal to what? Equivalent to what? 142 grams. Now 2 grams will then be equivalent to what? 142/80 times 2/1. So we can do this justice here. We have 40 here. So 40 divide we have will be what, 3.55 grams. That is what we have here. So you can see now there's something I want to point out here. Before you solve this problem, you need to understand what happens here, what it really means. You see how we move from there all the way towards to compare it based on the balanced chemical equation, which will always give us the basic information on the mass and what moles. Now, because we are asked to get the information in moles, that is in grams, that is why we work with grams only. In some cases, you might be asked to find in moles. Where you are asked to find in moles, that means every other information will be converted to moles. Perhaps let's say that you have these things in moles here. What you do, this one will be in moles. So from there, you work and solve the question. Thank you so much for being part of this class. And if you are joining for the first time, we want to encourage you to subscribe. And if you have a question, leave it in the comment section. We'll always attend to you. And then share, like, and we hope to see you again. Thank you.